simplifying radicals. Remember, the most common radical that you are familiar with is, in fact, this symbol. It has a root index of 2. This is actually called a square root because it has that 2. We also talk in Algebra 1 about this. This is a cubed root. And that root index, that little number there, is going to be super important. It's going to tell you how many you want in a group. When we talk about simplifying radicals, you can do this in a couple of different ways. If you watched the video for Coach Greenacre, you saw that you, in fact, are best off if you break your value into a perfect square and some other factor. When we're simplifying radicals, we're trying to break this into some kind of whole number that is usually a perfect square, and whatever is left. So I'm going to show you 2 different ways. I don't care which way you do this. You choose. I will show you a shortcut on the calculator after you've shown me that you can do this by hand, and then you can use whatever method you want. If we're looking at the square root of 72, tell me what are the factors? What multiplies to be 72 and one is a perfect square? 9 and 8, right? So we would say the square root of 9 times the square root of 8, where the square root of 9 is a perfect square, which is just what? So we get 3 times the square root of 8. Now we can even go to our calculator and we can say, okay, the square root of 72 is equal to 3 times the square root of 8. It's true, woohoo, yay, we did well. Okay, that is one way. Sometimes finding that perfect square is not super easy. So another way we could do this is going back to the factor tree that we did in 6th grade. In 6th grade, we learned how to break everything down into primes, right? So what can we, do you want to use 9 and 8, or you want to use some other factors that make 72? 9 and 8. Okay, we're going to stick with that. Now, these are not primes, right? Remember, primes, only factors are 1 in itself. So we can break 9 into what? 3 times 3. What can we break 8 into?
Nothing.
4 and 2. And these are all primes, but this isn't. What does 4 break into? 2 and 2. So I could rewrite this as the square root of 2 times 2 times 2 times 3 times 3. Do you see that? Because my prime factorization going back to 6th grade is 2 to the 3rd times 3 squared. Do you remember that? It's a long time ago. Again, we're looking here. Well, 2 times 2 is 4, and 4 is a perfect square. So we're going to put that outside. 3 times 3 is 9. 9 is a perfect square. We're going to put that outside. This 2 is not a perfect square. It has to stay inside. So I could... Oh, we didn't finish this one right. That's okay. Rewrite this one as 6 on the square root of 2. Now, I want you to notice this does not match this. These are both technically right. This one is the better, because this can actually be broken down into the square root of 4 times the square root of 2. Square root of 4 is 2, which is how we get 6 on the square root of 2. Okay, so be careful when you're using your calculator. It can trick you. That's why I'm going to show you a trick so you don't get tricked. Keep in mind when you're breaking this down into primes, pairs go outside, singles stay in, right? So if you have a date, you get to go out on a date. You go to the movies, you go to a restaurant, wherever you're going out. If you're single and you have no friends, you have to stay inside, which is a real bummer. All right, so make a little star here. Pairs go out. Singles stay in. Do you think you can do one? Do you feel okay with this? Yeah? You want to try one? What if we did, let's do the square root. Oh, I'll give you a nice one. Square root of 18. What would you do here? Talk me through it. Okay, so it splits into 9 and 2. Are those primes? 2 is. 9 is what? 3 and 3. So this is square root of 2 times 3 times 3. What are we going to do? 3 will go on the outside. What stays inside? Square root of 2. Done. How do you feel about that?
Good.
Okay.
Amazing.
All right. What if I gave you this one? This one is kind of ugly. Square root of 126. Now, this one is not super easy to find a perfect square on. And to be honest with you, it's kind of long. What do you think we should break this into? 2 and what? 2 and 63. What's 63? 9 and 7, and 9 is 3 and 3. So we could write 2 times 3 times 3 times 7. What do you think that simplifies to? 3 on the square root of what? 14. Go ahead and multiply it. So, real quick, some of these get really big. So I want you to go to your calculator real quick, and I'm going to show you a trick. Could do 9 and 14. Or you could do this. I want everybody to hit menu. 2. What are we breaking this into? Not the greatest common factor, just what? Just factors. Go 2, 3 right here. And when we do that, I want you to type in 126. So you're just kind of skipping this step. And I don't feel bad showing you that because you've shown me you know how to do it. So you could jump straight to here and save a little bit of time. Okay? But wait, there's more. What if I threw some variables in there? Would that mess you up? It shouldn't. Don't overthink this. It's the same concept. 24 y squared. You can use your trick. What's this? What are the factors of 24? You can use this. Break it into primes. Menu, 2, 3, 2 to the third times 3. Yes? It's a lot faster than hurting your head. So we get 2 times 2 times 2 times 3. But then I also have y and y. Are we still looking for pairs? Yes, this is still a root index of 2. Here's a pair. Here's a pair. What is this? What's going outside? 2y. What's going inside? 6. Done. Now you cannot do the variables in the calculator, but you can do the numerical values. All right? Another way you could do this, if I gave you the square root of 45 b to the third, if we take and write the square root of this, we get 3 times 3 times 5. Now, I'm going to leave this b to the third. Sometimes you're going to find that some of our variables get a little bit lengthy. Remember, this is a root index of 2. I can take my exponent and divide it by 2. So 3b is on the outside and 5b is on the inside. Because this goes in one whole time, goes outside, and you have 1 left over. If you don't like that, you can always write it like this, and it will be fine. Anyone have any questions about that? All right, last thing I want to show you. What if I gave you this? Be careful. To the third. This is a what kind of root? Cubed root. How do you think that's going to change what we're doing? What do you think? So you're looking for triples. You're looking for groups of 3. And I know, now we're still doing 2, 3. So I get 2 times 3 cubed and z cubed. So I know look, and so you could even do your divide trick here. You could list them all out. You've got 1 whole and 1 whole. So 3z on this cubed root. Don't forget to write your root index of 2. How do we feel about this? Good. We feel pretty good? All right, so the paper I'm going to give you today is on simplifying radicals, and they have numerical values and they have exponent values. I am going to do one on the back with you, so I'm going to let you finish writing your notes, and I'm going to give this out. All right, so let's lay at 25. Do not freak out. There is a number outside already. That's okay. That means you're going to do a -4 times whatever of these goes outside also. So we're not going to worry about that -4 right this second. I'm going to say menu 2, 3 for 216. I get 2 to the third times 3 to the third. So I'm going to write 2 times 2 times 2 times 3 times 3 times 3, x, x, y, y, z. And I'm looking for what? What is my root index? Looking for pairs. My root index is a 2, right? So here's a pair, here's a pair, and a pair. Yes? So I'm going to say, I gotta bring this -4 down. I've got a pair of 2s, I've got a pair of 3s, and then I've got x and y. What's left inside? 2 times 3 is 6z. Am I done? No, I got to simplify this. -4 times 2 times 3 is... So I have -24 xy on the square root of 6z. That is my answer. Okay? This is due tomorrow. See what you can get done.